Bing. We're pinging. Ladies and gentlemen, the adaptive immune system. This is, you understand that nearly every time you feel a little and most of the time that's your innate immune system is happening, is take care of everything. Even if you get, I had that 24-hour bug, that kind of a thing. The reality is your innate immune system was able to generate enough of a response early on to, let's say, a not overly virulent, meaning overly nasty disease entity, and you were able to fight it off relatively expeditiously. So you have that 24 to 48 hours. Next thing you know, you feel good. I was feeling lousy and I feel good today. That's the big deal, is that's a generalized response. This is very specific. So it does a lot of different things. It's really targeting an invader, a pathogen, or some type of abnormal cell. We'll get to the cell based. And there's really two ways to play it. And I know if I say it 100 times, it's not enough. The big difference is, are these free floating entities? Are they toxins? Are they bacteria? Are they viruses? Have they colonized the exterior of a lining? That's where the defense will go. That's what's targeted by antibodies. Those are broad-based things, as opposed to when they invade a cell. You're going to see a series of different markers are involved, a whole different process is involved. Once it distorts the interior of the cell, being on the surface is insufficient. Once it distorts the interior of the cell, now we'll be targeting the cellular immunity, which is a whole different thing. We're looking at cancer cells, transplanted, transfused, tuberculosis, because that basically grows inside of a white blood cell in your lungs to start. So there's a lot of nuances with regard to the system that you really do need to be familiar with. So things that it does in general, yeah, certainly. If it's gotten past your innate defenses, then obviously whatever degree of inflammation is probably insufficient. There's a whole series of basically proteinaceous materials dissolved in the bloodstream called complement that play a pivotal role in enhancing that inflammatory response. Those opsonins, certain things that play a role with regard to antibodies. But the reality is that the first exposure is a problem. So this goes back to, and eventually we're going to dovetail into certain kinds of allergies. So the worst probably example of this is the potential for anaphylactic shock. But when you're exposed to a foreign particle of some type, okay, that initial response, it takes your body a certain amount of time to ramp up your initial response. It's that second response that we're able to adapt to very quickly. That's the whole purpose, and that's part of this unit as well, as what immunizations are about. Why we use immunizations. Because we're trying to take that challenge period out of the way. Because a lot of the things that we have immunizations for are potentially life-threatening during that initial response period. And we may succumb or be seriously damaged prior to our immune system kicking in. That's really the sum and substance of that. So the nature of it, very specific. The response goes all, whether it's cellular or chemical in nature. So when we talk about humoral response, which is the system we're looking at now, that's sending antibodies, proteins transported in the plasma all over the place. And yes, the immunological memory is a very significant part of that. So that's a neat feature. So we're looking at humoral or antibody mediated versus cellular, which we'll look at later. So these all come from a modification of lymphocytes. Okay, these lymphocytes basically effectively morph into something called a plasma cell. The plasma cell is our antibody producing factory, and it produces amazingly large amounts in an amazingly short time after the priming period. Okay, and antibodies basically are designed to attach things that are not on the interior of the cell. They have to be within the bloodstream, within the tissues, laying on top of lining cells, etc. And effectively, they don't destroy. Okay? They target, they immobilize, they neutralize, they cause large aggregations, and basically, along comes mostly phagocytes with the assistance of complement to destroy them. That's the way it works. So by definition, extracellular targets, the offset, the cells themselves, we can either, cellular immunity either destroys the cells or it has a profound kind of inflammatory response or other kinds of activation. And you're going to see when we get into sort of the nitty gritty of the identifiers, these MHC1s and MHC2s. So MHC2, major histocompatibility complexes, are effectively these protein and sugar-based markers, protein and carbohydrates, glycoproteins, if you will, markers with things that are attached to them and play a significant role in the activating process. MHC2s are the ones that correlate to antibodies. MHC1s correlate to the cellular-based portion of the immunity. In the old days, when I learned about this, they coined the term antigen for antibody generating. All we knew was that antibodies were generated by foreign substances. Now the term antigen is different. And now, if you were to more accurately state what you're seeing here, the mobilizing of are not antigens, but foreign or unusual or unfamiliar antigens. Maybe the term foreign is the best, because we have self and non-self antigens. That's that whole idea of that sort of grace period when we're born and covered by our mom's antibodies that basically allows our body to go, okay, that's you, that's not you. Okay. And again, most of the time there's something that are really irregular in nature that are non-self. So now we have self versus non-self. Sometimes they are incomplete. This is characteristic of allergens. If you're like me and I've got the sniffles and I take a Zyrtec every day, okay, all the time, that's because I'm prone to allergies at certain times of year, spring and fall particularly, just like now. And those are incomplete. So hapten is short for half an antigen. And what it does, it bonds with some type of protein, completes the antigen, and effectively that's the spark to generate the response that's there. Okay, and so there's different things. They can be just specific determinants, which we'll talk about. And now we could look at them as self versus non-self. So complete antigens. That hapten, once it's bonded, has to be able to have immunogenicity so it can effectively target whether it's B cell or T cells, as you will come to see. B for antibody, T for, I don't know what, because they were basically matured in the thymus. And there's a whole lot when you get into about where they mature and things like that. And how well they can react. Okay. So ability to react with the activated lymphocytes and antibodies released. Okay. So all of these are things, proteins, certain kinds of polysaccharides, all of these things, and mostly, and then other stuff that's there as well. The haptems are too small, so they have to attach to some protein, as I said before, to complete it. And as you can see, there's certain things that are a little bit more complex, okay, that we see. So what happens is when we have a true antigen, okay, it will sometimes we'll have, and this is one of the big problems, the over responsive nature of your immune system. The biggest single problem we have, almost every viral disease, including COVID, were all about your immune system. The response was an overly exuberant response of your immune system. Influenza, whether it's mild or severe, immune system. That's what typically does the damage. Bacteria do it through toxins. Occasionally they do it through your immune system. So the immune system can be your word. And if you know anybody who has an autoimmune disease, and I have one that I'm treating differently now. That's comparatively mild and didn't surface, and that's part of this chapter as well to discuss autoimmune disease, which and many of them you do not want to have. It caught my interest because there are a couple of articles about Celine Dion with the stiff person syndrome. Are you familiar with that? Okay, I was not. I knew she had a condition, and I was, and apparently it's neuromuscular in origin. But and again, the speculation is it's autoimmune. Understand, everybody, from a medical perspective, that when we don't know, a lot of times the default is we think it may be autoimmune in nature. So that's something else that you always see. So there's a lot of these things. Poison ivy is a resin. Okay. Interestingly, it generates a cellular response. Animal dander. How many of you have pet hair or those kinds of problems? A lot of people do. Thankfully, it keeps a lot of people out of our house. I'm allergic to cats. Good. Stay outside. Is that you like cats?
Yeah, I have one cat.
Okay. Detergents, cosmetics. My ex used to go every time we'd go in the days before Amazon. The only mall that was in proximity of us was up in Erie, Mill Creek. There was nothing for 50 miles around. She'd spend $300 on exotic cosmetics because she had to only get clean. There was never a weekend we didn't spend $500. You wonder why I was poor. Okay. So the determinant is the key area. As you will see, the structuring of the markers on the antibodies, what we call the variable part of the antibody, and indeed projections on the T cells when we get to the cellular immunity are based on the determinant. The determinant is that tiny aspect that effectively we create the antibody to bond to. So different kinds of populations, different kinds of antibodies, etc. This is a very important little nugget. It's the kind of thing that you can see an MCAT question. Why do we do it? It's when we look at simple molecules for years. I don't know how familiar you are with implant chemistry, or this is biomedical aspect. The original biomedical devices were made out of long chain polymers, long chain plastics, stainless steel, materials that were effectively had minimal antigenicity. So we would implant these. It turned out sometimes there were reactions that were unanticipated. Breast implants, they used silicone. They found out over time that silicone would shard off. In other words, body reactions would take tiny little microscopic fragments that would cause reactions. And they had to remove silicone breasts. We were using silicone implants in joints, okay, for artificial joints early on. Then typically when you're looking now, breast augmentation, they're typically filling again, a polymer enclosure with saline up to whatever amount is desirable. And they're usually creating a pocket for it with either in the breast tissue or in the muscle underneath it. I know how familiar you are with the plastic, the cosmetic aspects of that. In joint implantation, now they're constantly changing the biomaterials. For a long time, it was stainless steel on one hand and like a polyethylene plastic of some type on the other, because that avoided that sharding, that being able to take these tiny fragments that would cause reactivity. That was a standard for a long time. So that's why these are used. They have very limited immunogenicity. So it's and this is what it looks like. So you have this antigen, and it has a variety of these, we call them determinants. And this is what your immune system, it basically makes an antibody on its variable end. We'll review the antibody configurations, which you probably had. You probably had those. You certainly had them in biochem, but you probably had them maybe a little bit in cell and the variable change. So These are the self-antigens, okay, located on surface that are not antigenic to self, but maybe antigenic to other things in transfusions or grafts, and that's a lot of what we have to do. When they do graft-related, and I know the technology has changed. For the longest time, if they were looking, let's say, like they were looking for a kidney donor, they would typically, people in the community, maybe in the church, would, they would test their blood. They would do a screen of these major determinants. And if you had X number compatible, maybe there were 100 and you had 75, that made you a potential. And they could do other tests to see if they're compatible. So this is where the term MHC, very unique to the individual. So, and when we get to the lymphocytes, we're going to see that those MHC are, this whole process involves cells, specific macrophages or other lymphocytes that are able to effectively become what we call antigen presenting cells. Talked about them a little bit. There's some of they're in the liver, they're under the skin, they're in soft tissue. And the whole idea is they're constantly sampling the environment. And what they do is they latch onto a piece, and what they'll do is they'll present this tiny fragment, like my fingernail. And if it's judged to be foreign, that's what the reaction will be to that particular marker that's there. And everything will be based on that. The difficulty with cancer cells is they're constantly mutating, and those markers are subject to change relatively quickly. So a lot of times that the antibodies or cellular-based immunity constantly changes. So here are the two types: B cells, because they're from the bone marrow; T cells, because they mature in the thymus; B cells mature in the bone marrow; and the antigen presenting cells. They don't respond too much as they are part of the process of the creation. Okay, and this is where they are. So everything starts in the bone marrow. The question is where they mature. And we don't really, the term maturation and activity are somewhat confusing terminology wise. And that again is something I would watch out for when you're looking at uh, questions. And you're going to see a cell can mature and then still be considered naive. Naive means it's never been really presented. Once it's presented, then it's going to follow a specific line. So the terms naive and mature are not necessarily interchangeable, as you will see. I think I have that correct. So here, and again, you see the two different lines. These lymphocytes are born in the bone marrow, and a certain amount go to the thymus, and very limited ones become activated. And then the T cells, that's where the T comes from, and the B cells, where the B comes from. So it's a process. They basically, as you can see, maturation, B cells in both the bone marrow and the thymus. And this is part of what they do. There's things called, and I do not know that you have to know positive and negative ways that they mature. So they have to be, if they're competent, they'll recognize one antigen, and they have to be self-tolerant. And this is part of the problem when we talk about autoimmune diseases. A lot of times things will be created that are not self-tolerant, that are there. And then immunocompetent, the ones that are not yet exposed, these are the ones they've matured, but they're still considered naive because they have not been exposed. Okay, and that's a better way to express it. Go from those areas wherever the maturation occurred, and then they go to all the mostly lymph nodes, a certain amount to the spleen, etc., other areas where they're most likely to encounter. And again, most of they could be bloodborne, but frequently they're lymphatically borne because the lymphs tend to grab those things, particularly from wounds and injuries, surface damage. So at that point, once they encounter that naive yet competent encounters, then it undergoes a process called clonal selection. It involves a lot of things we don't have to get into. So at that point, it proliferates. That's where the term clone comes from. And the vast majority, and we're going to again look at the antibody line, nearly all of them become effector cells. A limited amount become memory cells. That's part of your immunological memory. So whatever analogy you want to use. To me, it's like, you've got a program you started in your hard drive, and you've got an app, and now you just have to go on there and activate. And B and T memory cells and even effector T cells, once they're there, they're always around, and that's a good thing. That's the beauty of effective immunizations, without me getting into my whole song and dance about ineffective immunizations. Start. It's okay. So, okay, so they're diverse. It's a diverse population. Trying to think if there's anything else. This is that positive and negative selections. So positive means they have to recognize self, and if they don't, they're tossed. Negative, cells that bind to self antigens displayed by, boom, they promote. So there's negative and positive selection. Not a big deal to us. Effectively, what happens in reality is of all the T cells that mature in the thymus, only about 2% statistically actually become potential T cells for us to fight things like cancers and severe diseases. And then we'll get a lot. Again, we don't need to go into all of that. These are those interesting antigen presenting cells that are so important. They can be B cells. They're mostly dendritic cells, which are the ones that we see in certain tissues, liver, spleen, anywhere under a lining tissue. They're always there. They're abundant. And a variety of macrophages. So as you can see, the dendritic cells, they're somewhat mobile, okay? And they're able to, once they latch on to something, they will have that ability to present it. They're really the best ones, and they're really the key issue, because technically, antigen presenting cells are part of the innate immunity, and they're sort of the bridge between the two. It's well stated, and that's what they look like. So macrophages, same thing all over the place. Okay, antigens to T cells, which not only activates a T cell, but will actually activate that and other macrophages. And macrophages are busy. They have a lot of ability in the process of doing. They're releasing more of those chemicals. And you're going to see some instances where we see hyperactivation of these systems. And that's part of some severe autoimmune diseases or autoimmune responses. So I don't know, did you cover toxic shock syndrome and micro?
A little bit.
A little bit, yeah. I mean, that's basically, it's like it super activates 20% of your helper T cells that produce this slew of powerful chemicals. And and that's where, again, it's the immunological aspect of things. Bacterial meningitis, same deal. It's an immunological response that's immediately life-threatening. It's scary. Okay. So B lymphocytes do not activate naive T cells, but they present antigens to the helper T cell, etc. So there's other aspects of this. So all of these things are some comparisons. And so now we look specifically at the antibodies, and it'll take us through. I'm trying to get to the important point. So the effector cell and the B cell in the antibody-based aspect of you is the plasma cell. So look at this. Once they are active, once they ramp up to production, which again takes somewhere between 7 to 10 days. So if you ever wonder, when you go to urgent care or to your doctor and they give you a prescription, you're starting to get a strep throat, you better take this for 7 to 10 days. Even the Z-Pack effectively is a 7 to 10 day dose that it's based on time released. That's covering the ramp up period until this 2,000 molecules per second for 4 to 5 days. Boy, if you did that per second, who could fault you for dying? Oh my God, I've been doing this for the last 5 days. So, and it's immense. So here you can see the primary response, cloning, activation, plasma cells, and the whole idea is this. The antigen markers, they tailor those active ends on the antibodies to that. So and there's our memory cell. So that just shows it again. So this is the important, that lag period. That first exposure. So for someone like me who was exposed to chickenpox or measles or rubella, German measles, when I was a kid, you had such a profound amount of immunological response. I mean, there was no need to take any booster shots after that. It's just boom. And we, in my generation, we all got this. Okay, 10 days. So that's the idea. That 7 to 10 day window you're trying to cover, and then they decline. The re-exposure, hours. That's, you're interested in medical careers, which you are. Every time as you're scrolling through whatever site you use for news, or you see an article, just look and see. Oh, there is, I see them all the time. Oh, measles outbreak in some state. Most of the time that's related to one thing: vaccination laxity. I'm not here to tell you there aren't problems with vaccines, certainly, but the big problem is the ones that have sort of proven the test of time is significant, and it depends on who you talk to.
Isn't there a measles outbreak now?
Yep, there is. I didn't locate where it was.
There's no post here, I think. I keep getting a bunch of parents at work telling me they don't want to do.
Did you want one?
They don't want to get MMR.
I know.
I'm like, okay.
Understand, there's been a lot of, I don't think it all started then, but back in the late 90s, people were trying to find why we're seeing such a vast uptick in effectively autism, or autism like what people always call the spectrum. Okay, and preservatives in vaccines are a big problem. For the longest time, they used formaldehyde, which is a toxin. They used mercuric compounds, particularly one called thimerosal. And thimerosal, mercury is a neurotoxin. Now, Friday night, if you're going to fish fry, which I can't do because I'm on keto and it's killing me. Hey, so much tartar sauce, so little time. Okay. Would you like fish fry? I'm Jewish. We like fish fry. Priest is always there. So, just saying, oh, you don't know what you're missing. French fries, coleslaw, tartar sauce. Good stuff. And around here, it's great.
Is it too late to switch my major?
To the Codfather?
I wish.
So you could say, I'll share the story some other time when we have more time. Nevertheless, the problem was if you went to fish fry, you and I, and we'd have more mercury in that than they would get in the vaccine. But our nervous systems are developed. An infant's nervous system is not. There is the problem. And this fellow in England did some research on that was faulty. It was shown numerous times to be unreproducible, inadequate in any number of details. It was published in a major journal in England, and every anti-vaccine person said, aha, see, I knew they were causing autism. The reality is that there's never been an article that has proved that, but by the contrast, there's never been an article that has disproved it. So there's nothing either way to say that it's conclusive to say it does or does not. So vaccines can be made without harmful preservatives. And as a parent, that's what you should, I feel, in a medical field, be aware of and encouraging your patients to do. Because, I mean, if you saw polio is a killer, measles is a killer. You may not think it, but it's a killer. So, and people don't realize that. And a lot of people, and there's a lot of anecdotal people who have seen problems with their kids because they get hammered with vaccines early on. I don't know if that's right either. I think there needs to be a lot. There's not the vaccine's not the only solution. It's a very complicated area. I don't think I'd have enjoyed going into immunology. This is a great chart. It shows you, and I just want to show you a couple more things. This is how it ramps up, as you can see on the first exposure, it ramps up to here. Look at that second exposure. It ramps up almost immediately to extraordinarily high levels. Okay, this is the part. I can conclude with this. We'll probably take an extra day. Naturally acquired, okay, this is like I got as a kid. Measles, chickenpox. Naturally acquired, what they call active immunity, is you have been exposed to it and you've created immunological memory. Artificially is what you had. You got the MMR. Okay? You had some type of, we call attenuated pathogens. Attenuated means it's been altered to preserve its antigenicity, to preserve that you have an immunological response, but eliminate the harmful aspect. That's what attenuation does. Live and dead is not really a good term because, viruses aren't alive or dead. Viruses are either inactive or active because they're not living. By definition, how could they be alive or dead? But the antigenic determinants are immunogenic and reactive and spare us the primary response. Well stated. That's active. Passive immunity is short term through mom. Okay, through nursing or directly through crossing the placental barrier. Classic way. Artificially acquired, this is injections of antibodies. They used a ton of these monoclonal antibodies, which were very effective during COVID. A lot of people poo-pooed them. They worked. Okay, because let's face it, they're trying to sell vaccines. That's what they're doing. If you had a side effect to a vaccine, you can't sue Pfizer. You can't. They're indemnified. WTF? You have no recourse. But the limitation of these is time. These degrade over time. So this is what you would do for a snake bite. And effectively that's what they are. When someone has a tetanus exposure and they are not tetanus current, you have to use a tetanus immune globulin. Same thing with rabies. There's no way, shape, or form that you can create immunity that way. So that's really important. So we'll look at the makeup of the immunoglobulins, which is relatively quick, and get into T cells after that. All right. Thank you. We're going. See you guys later. All but you, young lady.
Mhm.